Can you hear me?
I can hear you, thank you.
Right. Hi guys, my name is Fushia Viet. Okay, let's start. In today's unstable energy environment, businesses are increasingly turning to sustainable energy solutions to reduce operational costs, enhance environmental credentials, and prepare for a more sustainable future. This session explores the use of solar energy, batteries, and hybrid inverters in your business operations. We will also delve into the economic benefits, return on investment calculations, financing options, and the fundamental workings of these systems. Please take note that these systems are designed to handle a myriad of use cases. It is not a generic solution, and a consultation process needs to happen before any hardware is installed. It can't be stressed enough that a professional should be used. Solar energy basics. Solar panels harness sunlight to generate electricity through the photovoltaic effect. This process involves the conversion of sunlight into direct current electricity. Proper installation is crucial for optimal performance. Panels should be positioned to receive maximum sunlight exposure throughout the day. Batteries in solar systems. Batteries store excess electricity generated by solar panels during the day for use during the night or on cloudy days, providing uninterrupted power supply. The most common battery type in solar systems is lithium iron phosphate. They are known for their longevity and deep cycle capabilities without significant degradation. Inverters. Super hybrid inverters are advanced energy management systems that integrate solar panel power generation, energy storage, and grid interaction into a single unit. They offer a wide range of capabilities to optimize energy usage. These units can typically be interacted with via an app or a web interface. Solar system calculations. To calculate the size of a solar system for a business, one must understand the following limiting factors. Panel constraints, the amount of space available, shading, annual weather data, panel inclination and orientation, and budget. Battery constraints, space availability and your budget, economic constraints, finance available to fund the solar project, current generation available. Generators are typically present on commercial properties. The role of a generator must be determined. The following cases can happen. Baseload generation. If a solar system cannot produce enough to supply all the energy needs of the business. Backup generation during load shedding or bad weather. Time of day use, e.g. evening loads or early morning loads. One must also determine the role of the solar system. It can be completely off-grid with no generator backup. It can be off-grid augmented by a generator. It can be partially off-grid. It can handle load shedding with limited evening consumption. It can be a cost saver, use solar just to shave the Eskom bill, and then just a mere load shedding solution. The following example illustrates how a solar system will be sized to get commercial client completely off the grid with generator backup. The first thing to do is to gather usage information. Typically, one should use an energy logger to gather usage data. This is important as the company's energy consumption profile throughout the day needs to be determined. Electricity consumption, how much energy your business consumes is a big deciding factor in how much in your system. Generally, most solar suppliers will review your existing energy consumption through your bills, half-hourly data, or any other consumption data. This typically tends to be in the total kilowatt hours. The size of your roof and available ground space, this is a key factor as it determines the number of panels that can be installed. It's also important to consider your roof stability, whether it can withstand the weight of the panels and how they will be angled. Ground mount systems can take the shape of shaded carports, awnings, or linear arrays. Solar availability. The amount of energy that solar panels can generate is dependent on the hours of sunlight you get in your area. The varying amount of hours of sunlight will affect the number of solar panels that you'll need. Compare Cape Town and Pretoria. Cape Town has long, dry summer days and miserable, rainy winters. Pretoria has dry winter days and summers with mostly afternoon showers. Analysis of data and work out a load management plan. A load management plan is one of the most crucial steps in alternative energy systems. In most cases, if this is not done, it will be to the detriment of the customer. Loads need to be identified during the data gathering exercise. It is important to know when loads are running, when they should be running, and if they are necessary at certain periods. An example can be a compressor switching on and off during the night to keep the pressure vessel pressurized, geysers running at night, types of lighting, and when they run, computers, borehole pumps, etc. The way motors start up is also crucial. Motor startup circuits include the following. Direct online. This startup method has a very high startup current and it will influence your inverter sizing. Star delta. It's common for large motors, but it's outdated. And then we have soft starters. They cause a gradual start of the motors. They're programmable, and it's the most modern unit that you can employ. Planning needs to be done to determine how the loads can be reduced. Employ soft starters or star delta starters on motors. On centrifugal fans, you can employ motorized gates or louvers, which will reduce startup current. Reduce or inhibit unnecessary loads at night. Put geysers on smart breakers. Automatically inhibit compressors, lights, borehole pumps with smart circuit breakers. Switch off computers. A lighting audit can also be done so that in order to move over to LED technology, use motion sensors to automatically switch lights on and off. System calculation considerations. In terms of an inverter type, an inverter should be chosen according to the results of the load management process. Hybrid inverters come in various sizes and can typically be connected in parallel. The size of the inverter should be about 30% more than an average power consumption. Depending on the make, some inverters can handle spike loads of 20 to 50% of their rated capacity for 5 to 10 seconds. This will be perfect for motor startup spikes. Batteries are expensive and careful considerations should be made when planning your system. The primary functions of battery is to store energy when there is no solar, Eskom, or a generator available, and then to release this energy when a primary source is absent. Here are a few use examples. It will release stored solar energy at night to run essential equipment like servers. When clouds obscure the sun, it will release stored energy to ensure stable supply. During load shedding, it will ensure essential loads are serviced. During the early mornings and afternoons, it can release energy when solar is not available. Solar panels. The number of solar panels must be calculated to be able to achieve the required loads. The time of day usage can also influence the orientation of the panels. If there's a requirement for early morning loads or late afternoon energy, some of the panels can be orientated east and west with the bulk facing north. Motorized trackers can also be used where the panels are kept facing the sun during the day. A typical calculation will look like this. The panel amount will be equal to the daily power requirement divided by the panel output times 5.5. The result must be adapted to suit the input of the specific inverter, and this calculation needs to be done by an expert. Load profiles can consist of the following. You can have a grid-tied cost saver. The panels will replace a component of Eskom or generator usage. This will increase your profit margins. Grid-tied cost saver with battery backup. What this means, excess solar can be used to charge the batteries. The energy can then be released as required when solar is low. You can do a grid-tied solution with excess solar. When available, excess solar can be exported to the municipality or ESCOM. This can be for profit, or you can use this exported power as a virtual battery. You can, for instance, you can export during the day and then import at night, making the net meter reading 0. As you can probably see, these calculations must be done by a professional with intimate knowledge of the hardware. Economic benefits. Savings on electricity costs. Solar systems can significantly reduce your electricity bills, helping your business save money in the long term. It can reduce your dependence on diesel generators. By using solar energy and energy storage, you can reduce or eliminate the need for costly and polluting diesel generators. You can manage energy inflation. Solar systems insulate your business from rising electricity and diesel prices, and it will provide stability in the face of inflation. You can optimize your self-consumption. You can maximize the use of solar and stored energy, reducing reliance on grid electricity. Energy independence. You can ensure uninterrupted business operations during power outages without backup generators. Grid feeding. Solar systems can feed back into the grid when there is excess energy available. Imagine a company that is closed on a Sunday, selling electricity to ESCOM, increasing your profit. Tax incentive. The government has introduced the Section 12B incentive. For a limited period, the tax incentive available for businesses in terms of Section 12B of the Income Tax Act. Section 12B provides a deduction in respect of the cost of machinery, plant, implements, utensils, or articles used in the generation of electricity through renewable resources. The qualifying renewable energy assets must be owned by the taxpayer or acquired by the taxpayer in terms of an installment credit agreement as defined in the Value Added Tax Act and brought into use for the first time as part of the taxpayer's trade. The deduction also applies to any improvements to the above-mentioned renewable energy assets and to any foundation or supporting structure that is deemed to be part of them. The capital allowance for the cost of renewable energy assets is spread over 3 years, 50% of the cost in the first year, 30% in the second, and 20% in the third. However, an exception is made for PV solar energy not exceeding 1 megawatt, which is fully deductible in the first year of expenditure. Return on investment. The current return on investment per annum on 100,000 Rand is around 5.5% for property, 6.89% for Satrix, and around 6.25% for a call account. Thanks to ESCOM's devastating price increases and rising fuel costs, you can invest that same 100,000 Rand in a PV solar system. That will be enough for a 5 kilowatt grid-tied unit, and you will be looking at returns of 40%. Simply put, there is no other investment that offers this return, plus the security of knowing you will have electricity. Energy costs cut directly into your company's profit margin. With the extra cash flow that the solar system generates, company growth will be directly impacted. Backfeed to the grid will also have an impact on your return of investment. Financing options. You can have bond increases via banks. You can explore the possibility of increasing bonds to raise funds for your renewable energy project, facilitated by financial institutions. You can have bank loans and other funding sources. Traditional bank loans as well as alternative financing sources can be used to secure funding for your solar energy and super hybrid inverter projects. There's also rent-to-own or leasing options, which can be also explored. These financing options can help you realize your renewable energy goals, reducing electricity costs and enhance the overall sustainability of your business operations. Environmental benefits. reducing your carbon footprint. Solar energy with super or hybrid inverters reduces greenhouse gas emissions, which contributes to a cleaner environment. Promote corporate social responsibility. You embrace sustainable energy to demonstrate your commitment to corporate social responsibility and environmental stewardship. Meeting sustainability goals. Achieve your sustainability goals and enhance your business's reputation by transitioning to renewable energy sources. In conclusion, incorporated solar energy systems into your business can lead to substantial cost savings, environmental benefits, and long-term sustainability. Embrace the power of solar energy to secure a brighter, more sustainable future for your business. It is of the utmost importance that your investment in a solar system be done with a professional installer. It should be designed to your specific needs to ensure that there are zero interruptions and that you can experience an optimal return on investment. Thank you.
Thank you, Fushay. Okay. To the attendees, are there any questions or specifics if you would like to ask Fushay in terms of your actual businesses? I do realize the presentation was very generalistic, but we do realize there's quite a few different types of businesses and industries represented here. So if you would now like to ask Fushay any direct questions, we will take them. Okay, I can see Ati's hand up first. Thank you, Ati. You may go ahead.
Thank you, Mr. Chair, and also thank you for the informative presentation. So I've got two questions. In terms of lifespan, when we look at the solar panels itself, how long are we looking at? Is it 5 years, 10 years? And also, what is the newer technology looking at in terms of, solar panels? Is there newer technology, in the forefront, up and coming? I think that's my one question. And then the other question, as you mentioned, batteries can get very, very expensive, even though, high in demand. I would like to find out how's the technology coming insofar batteries to make this option more affordable for businesses. Thank you, sir.
Thank you, Ati. Okay, firstly on the solar panels, the technology is plateauing. So you get about, your good panels, you get about 25% efficiency out. There is room for improvement. You get bifacial panels these days that can accept energy from the backside as well. So if you have reflections, it will greatly increase the output of the panels. They are highly robust. If you look at your guarantees on your linear output of those panels, it ranges between 20 to 25 years. So that's high for an electronic device. If you look at inverters and batteries, you typically get 10-year guarantees. We have, in terms of cost, we have experienced a remarkable downside on the price of especially batteries and solar panels. Typically, we would adjust our prices once a year, and this year we've done it 3 times already on the downwards. So there's a case of supply and demand. There's a high supply available these days. So batteries are becoming increasingly affordable. About 2-3 years ago, batteries were not even included in commercial installations. It was just grid-tied solar panels and inverters. But these days we do more and more battery stacks that we include in our installations. Also, if you look at the return on investments, it was 7 years a few years ago, and now it's between 3 and 4, including batteries. it's offset, it's the calculation, Eskom makes the calculation easier, and diesel prices, it's sustainable. Battery technology will go into next stages. I've seen various iterations of new technology coming out. The lithium iron phosphate batteries that we currently use are highly stable. You get 6,000 plus deep cycles out of them, so they're quite robust.
Thank you, Fushay. Hedley?
Thanks, Julian. Good afternoon, Fushay.
Hi, Hedley.
In terms of an installation, and once an installation has been completed, there's the certificate of compliance that it's issued. What are the things that one needs to keep aware of and be and understand? For instance, one of the items that comes to mind would be the earthing resistance criteria, and how would they adjust that if they needed to?
Okay. Thank you, Hedley. Yes. So there's a few steps that needs to happen. Our process starts with consulting. We outsource consulting to the engineering firms, where they will look at your system design. They do the drawings. They ask the questions. This will be presented to the municipality. After installation, the installation needs to be signed off by a three-phase electrician that's compliant. The earthing resistance needs to be. We add extra earthing equipment. Each panel, for instance, gets earthed, and via various earth rods around a company's building, it be earthed. That earth is separate from the building earth. They are joined, but for instance, in a high veld, it's crucial, for lightning or lighting protection. So we run thick cables, and we put little short lighting conductors on as well. Now, everything, there's a SANS directive out. We all need to adhere to that. So there's a checklist. Your COC that will be given to you will be on top of your current building COC. These installations cannot be done onto a non-compliant building. So typically we fix buildings wiring and do a new COC before a solar system will be incorporated. Yeah, one must be aware that these things are expensive, and we've seen fires where they are non-compliant typically. Does that answer your questions?
Yeah, thanks. Just the question really that I was interested in is what would, on the COC, there's a lot of guys issuing these things. What would the earthing I'm particularly concerned about the earthing resistance in terms of electrical conduction and lightning conduction and the high fault. What would one be looking at in terms of the maximum resistance value on a COC for earthing?
I see what you're saying. We typically go for less than 10 ohms. If you cannot reach it, you need to dig a bigger hole and use earthing compounds. You will be compliant around about 50 ohms, but that ohm value varies, so you have to distribute it via various earth rods, and connect those earth rods together to form a loop. Yeah, between 10, we're happy when it's between 10 and 30 ohms.
Okay,
At
that's
a
great.
high,
Thank you. Yeah.
at a high voltage, obviously.
Yeah. And that's on a commercial building and as opposed to a residential, because I believe the residential should be below 2 ohms, if I'm understand it.
It varies. You use various voltages to test your earthing. I'm talking about lightning. So
Okay.
if you apply a high voltage to your earthing, it should be around about 10 ohms.
Okay.
How's it? That 2 ohms is really impossible to maintain. You might do it on installation day and water everything up, but that will gradually fade away and vary according to rain. If there's a specific danger area, in Gauteng it's highly problematic. Then we apply ourselves more than areas with lower lighting, like the Cape. You rarely have lighting there. But here we are quite anal about having a extremely good earthing.
Yeah. Okay, thank you. I have another question, but I'll let someone else go first.
Sure thing.
Thank you, Hedley. Luwani, sorry about my apologies of not pronouncing that correctly.
Hi guys, my name is
Hi.
actually Masha. I'm standing in here for my boss, which is Lubuwani Nemabandu. I wanted to find out, at the first you said that there are documents that we can download there at the chat box, but I cannot see anything.
Oh, my apologies, ma'am. If you go into the chat box and go right, just scroll up, I think it would have probably been moved by
Okay,
now.
I
Okay.
did, but I can't find anything.
Okay. You know what? If you just put your email address into the chat box, I'll email them
Okay,
directly to you.
cool. Thank you.
Is that okay? Pleasure.
Yes, thanks.
Okay.
If there are no other questions, can I go with my second question there, Julia?
Yeah, I don't see any hands at least, so yeah, please go ahead.
Thanks. Fouché, just in terms, we've spoken a bit about solar power. What is your experience at this point in terms of wind power for regenerative source?
Lately, it's you really need to justify that. It's not allowed everywhere. The cost of those units are relatively high compared to solar panels. Those wind power scales with diameter and height. So your surface winds are typically low compared to 50 to 100 meters up. There you get your generation. So it really must be prevalent, and it needs to be allowed. We've dabbled in that on farms where you'll have a farm that has high evening winds. You can, instead of a battery, then you can employ something like that. The ROI of those units are 5 to 10 years. But you really need to do your current weather data. Do a combination of solar and wind where possible, especially if you're in a Cape. For instance, in Pretoria, it will make zero use case. There's no case for a wind generation farm in Gauteng. Eastern Cape, Western Cape, yes.
Yeah, my thinking was more along the lines of coastal belt, where you obviously pick up your wind in the late afternoons and evenings.
Absolutely.
I've obviously done a little bit of research or looking into it, not really research as such, but and there's one particular brand that is advertised that unfortunately gets a very bad rap in terms of their service and backup.
Yeah.
And I'm going to name them being TESUP.
Spell, please.
TESUP. And they claim to have a silent 5 to 7 kV or kilowatt wind turbine, vertical wind turbine. Unfortunately, they're made in Turkey. And it appears that their product quality is not what it is, but it's a brilliant concept. And if the concept worked, it would be awesome along the coast.
Sure. If you can, you need to look at the specs. Obviously, coastal mechanical units needs to be highly robust. Again, if you want nice consistent wind, you need to go high up. You need to look at the specific turbine and do your and look at your specific wind power and direction. These vertical wind units are omnidirectional, which is nice. But yeah, you need to do your due diligence on them, man.
Correct, yeah, and that's what's got me super worried about them.
The biggest problem is compliance. In municipal areas, you're going to have to jump through a lot of hoops to do a high structure, and it's going to be costly. You're going to buy one of these 5 kilowatt units for 10,000 rand, and then you erect a structure to support it. I mean, it doesn't help if you just put it on a roof. You will not get sustainable generation. It needs to be up. Again, it needs to be high.
Sure. Thank you.
Sure, Edley.
Thank you. Okay, I see a hand from Feroz. Feroz, you can go ahead, and then Yonita.
Hi, Feroz.
Hi there. We've met, and thank you for your presentation. Yes. I know it was very general today because you actually have a wide range of RMI members. But,
yeah, it's different, unfortunately.
Yeah, so the situation in vehicle test stations is rather unique in that our power and load consumption might not be high, but at the time the vehicle passes over the brake roller tester, there's this big surge in power requirement. And up till now, our options have been obviously high capacity generators, from 45 kVA upwards. And you did allude at some stage that there could be a combination of a lower requirement generator and supplemented by batteries, inverters, and solar. Do you have any case studies of any installations that have been done where there's these kind of combinations or not? Thank you.
Ferozi, I actually did put a logger onto a Class A. Was it Class A? It's for trucks, correct? The test station. And
that's right.
Yeah, this particular test station employed soft starters, and I must say, it's those brake test units with soft starters. They do not have they do not even come close to the rating of a generator. The problem with the generator is that it has to maintain its own speed mechanically. It has to react to power requirements by physically opening or pumping more diesel. With an inverter system, it reacts immediately. An inverter system in combination with soft starting technology will halve, if not more, the requirement. Now, if you use, for instance, a 5 kilowatt motor, if you start it direct online, it can do 10 times its own rating. But these motors don't get used to their full capacity. 50% if that. And with the soft starter, the soft starter will do two things. It will start up those rollers, and when you do the brake test, it will basically turn against the brake of the motor, if I'm not mistaken. Now, those aren't spike loads in terms of long duration. It's not a spike load. It's more gradual in terms of 2 to 3 to 4 seconds, and these inverters are more than capable to handle them. I'm busy putting together a test rig for a Class A. We're gonna test it, and I will share the results. I'm gonna do a 25 kilowatt inverter, which will be able to run your whole business, and then also to absorb those brake testers. There's a definite use case for vehicle testing stations. I have no doubt about it. These inverter systems are actually more capable than a generator to run those units.
Thank you very much. That's good news. Is there a specific make of inverter that is better than others? And do you want to say what that is?
Yeah, no, sure. We primarily use Daya or Sunsync. They have proven track records. They come out of the same factory, but they just run on different software. The bigger industrial units can handle 50% of their rated output for a few seconds, and that's important. That's what you want to see in these systems. If you have it run with the correct batteries that can handle the current of startup loads. So you have to basically over-design the battery pack a bit. You can't, for a 25 kilowatt system, you can't have a 25 kilowatt rated battery. It must be a bit higher. But they are out there. They are available. They have the inverters and the batteries have 10-year warranties. Yeah, we have employed these units in various sizes up to 500 kilowatts, industrial applications. And motor startups are not unique to vehicle testing stations. In an industrial environment, you have all kinds of motors that start up. And what we've seen in some cases is where you say you have two test stations, two lanes, Class A lanes, for instance. You can easily just inhibit the one test station from the one lane from starting before the other one is finished. There's various ways to do this. But yeah, soft starters and a correct inverter. That's the thing.
Thanks for sharing. We look forward to the case study on the A-grade station that you're doing. Thank you very much.
Thank you.
Thanks, Rose. Bionita, you can go ahead, and then I see Hedley's hand again.
Hey, Julian. Good afternoon, Fushia.
Are you, Anita?
I have one or two questions. The first one is regarding health and safety. With the changes to alternative energy, I assume that the Health and Safety Act would also be changed, and seen in that light, are there officers or people already trained to handle the health and safety at businesses? Because I can't see that it will be handled in the same manner as ordinary electricity. I'm not sure if I'm correct or not. And where will the training take place if that is done? That's my first question.
Okay. Should I answer?
Yes, yes.
Okay. So in terms of health and safety, obviously there needs to be key individuals that is trained on how to handle the systems. These systems are typically hidden away and fenced off or enclosed. From the panels to the wiring, from the panels to the inverter systems. There's directives from government that's very specific on how these installations should take place. Specifically to increase, to have them be safe. There are courses that can be done, but we have never have a use case for personnel of a company to do that. It will, if everything is according to SANS, there's really no requirement. A definite requirement, though, is for regular checkups to be done by the installer, or our company, for instance, offer yearly checkup, yearly or half-yearly checkups, panel cleaning and stuff like that, inspections to be done. These units should typically not be visible or accessible. Okay. Does that answer your question?
Yes, it sounds like there's going to be in future quite a bit of training, but I hear what you say. Thank you. The other question that I have, yes, I'm listening.
Yes. Yeah, sorry, these systems are being, should be monitored remotely by a professional company. If something goes wrong, you must not be the first to know. The company who looks after these systems, they will get notifications, and they should be on site before you even know something is wrong. These are expensive units, so you can't just install them and walk away. That's for bucky brigades. Your installer should offer after-sale service. It can be a maintenance plan with a monthly fee or something, but it's definitely recommended. It's crucial.
Thank you. Then the second question that I have is about wind farms and wind power that you spoke about a little bit earlier. I'm quite a big fan of Sutherland, and I went there a few months ago, and I struggled to find from a very small town to it's becoming very not big, but wind farms are being set up there. It's a 5-year contract, and they are selling houses and they are renting out rooms in houses. Obviously, there's wind and there's sun. Only 20% of the year it rains there. 80% of the year it is sun due to salt that's being there and open skies to observe the skies and the stars. So can one combine those two? That's my first question. And then if you put the power or in a battery, can't that not on a big scale be taken or to the rest of the country? Because it's a very big project. Can you not distribute it to the rest of the country?
Yes, no, absolutely. If you look what's happening in South Africa, by hook or by crook, we are at the forefront of renewable energy these days. Albeit on a beyond a Shambok. So wind farms are popping up everywhere. with massive battery packs and combinations. In the Northern Cape, they're doing concentrated solar projects, photovoltaic units, big lithium ion battery banks, and on a coast there's massive wind projects going on. There are constraints though to the grid. In some areas you cannot put up more alternative energy plants because of the constraints of the local grid. So the local grid can only handle the historical consumption of that area. Now you're pushing megawatts or gigawatts into that grid. So there's everything needs to grow organically. There's private companies putting up power lines now. That's one of the big things in South Africa now, is who will fund the power lines and who will manage it. Eskom is alluding to the fact that they will split up and be, one of the components of Eskom will be a distributor of power, and that just managing the grid, not producing energy but distributing energy. And that it will be their function to put on or cause this to happen. So yeah, it's happening, and it's happening at a steep pace. I see the amount of slots available gets less and less because of the fact that the grid can't handle these massive projects. But it will happen.
Thank you. And just the last question that I have for Sheer is, a few years back, I listened to a program on the radio where they spoke about this. It's as if the professor that they spoke about could foresee what was going to happen. And they spoke about nuclear plants, but on a much smaller scale than, for instance, Kuberg and Pebbles. I'm not sure. I'm not.
At a
I do not know.
PBMRs.
It sounds like that, and
it's
it was
pebble bed modular reactors. Yeah.
yes, and it sounded very simple to put together, but there was a big outcry, and I really don't understand if it can help. And it's so simple as it seemed, as he explained. Why can't we do that as well?
I'm a big supporter of nuclear. I mean, we live in South Africa. We have a lot of uranium here. The PBMR project, if I can remember correctly, it was here in Centurion, where their head offices were, and it just fizzled out. I must actually find out, because I have a friend who worked there on that project as an engineer. But the PBMR project was to create, in inverted commas, a safe nuclear stations, small scale nuclear stations. But I mean, if you can have nuclear as base load generation and get rid of the coal-fired power stations, that will be wonderful. We have thousands of years of uranium available to run those units, and if it's obviously managed correctly, that's wonderful. PBMRs, I mean, if you can have one in your local vicinity, I'm not sure if I'll be happy. They say it's safe. It can't thermally run away, so why not?
Thank you for sharing.
Also, I think these days, in 2023, the appetite is 10 times higher for nuclear than 20 years ago when they did that PBMR project. I think the winds has changed in terms of acceptance of nuclear, unless it's government projects that will escalate 10 times the original cost. You know what I'm saying?
Yes, I'm with you. Thank you so much for sharing. It sounds very interesting.
It is, eh?
Very.
Yeah. Thank you, Janita. Koshe, I must say, just from my side, I think the appetite for nuclear now has been fueled by load shedding. I think people are just fed up.
Absolutely.
Just a personal opinion. Headley, I see your hands up.
Thanks, Julian. Yeah, just for what it's worth, I've got 3 points, and perhaps just to answer the PBMR situation, the government actually pulled the funding on it because they claimed they couldn't find a customer for it, and that's what happened to the PBMR.
Thank you.
Don't know who Eskom is to the government, but anyway. What is interesting to me as well, for shares, I've noticed there's a lot of emphasis on the kVA rating of a battery, but very seldom are you, and very sometimes with a lot of difficulty, are you able to find the amp hour rating of the battery, or that, you know. So if you look at a Blue Nova 8 kVA battery, you're looking at that as a 300 amp hour battery unit. You look at a SunSync 5.1 kVA battery, it's a 100 amp hour battery. And the amp hour, as far as I understand it, is pretty much the storage capacity, and the kVA is the delivery volume or rate of capacity of the battery. And I think that's one of the interesting observations that I come across, and there's seems to be a bit of a misnomer in that. The second point, going back to health and safety, we understand that a majority of these batteries are lithium ion or lithium phosphate, and the question really is, should one of these batteries catch fire? How do you deal with that? What kind of fire extinguisher do you need to use in the in fighting a lithium battery fire? And then the last point I want to raise with you is, you mentioned the monitoring of this by the installer of the system. Is that I know I've got it with one of my SunSync systems with my installer. Is that a service that you offer as well, where the units that have been installed are being monitored online by your team?
Yes.
And I'll shut up now.
No problem. Okay, if you look at the power storage capacity of a battery, you talk about 100 amp hours, for instance. Now, you can have a 24 volt battery on a 3 kilowatt, you know, these small little inverters, they use 24 volt as a base. So 100 amp hour, if you look at a screen, 100 amp hour battery equals the voltage of the battery kilowatt hour rating of a battery is the amp hours times the voltage. So if you talk if you talk about say a 5 kilowatt hour battery that you typically use in a SunSync or a Daya unit, that 5 kilowatt hours will be equal to the amp hour rating, that's 100 amp hours, times the voltage, which is about 50, around about 50 volts. So if you can see there, the 50 times the 100 amp hours will give you the kilowatt hours. I put that, this power equals voltage times current, that's amps times volts, or volts times amps. There it is, amps times volts, and then times and hours, that will give you your 5 kilowatt hours. So to say 100 amp hours is really not a good indication. You know, we work with batteries up to 500 volts. So you can have that, and that will just happens like that. So you can have a 500 volt, 100 amp hour battery, but the storage capacity of that battery is then 50 kilowatt hours. Does that make sense?
Yes, it does. It does indeed. I'm thinking more from a, you know, the sort of typical batteries that we encounter, though, and
Oh,
less
yes.
industrial size. So, if I take the example that I used is the Blue Novas that I've got, 8 kVA, 48-volt batteries.
Yeah, you don't say you use kVA. The amperage of the battery is important. Not we don't use a kVA rating. If you talk about the capacity in terms of putting power out, is that what you're talking about? So, for instance, you can have a 5 kilowatt hour battery like that, but it will be, for instance, rated. You have a C rating that they talk about in batteries. A C rating for this above battery will be 100 amps. Typically, your lesser batteries will have a 0.5 C rating, so that battery will only be able to give a 50 amp output. If you want to do a VA rating, you know, in this instance, it will be 100 amps times 50 volts. But, you know, that's a misnomer. We talk about 1C batteries. That will tell you what the quality of the battery is, or what the current capacity of the battery is. So sometimes you have an 8 kilowatt system. If you use 1C batteries, you only need 2 batteries. With 0.5C batteries, you'll need 4. So that's how we spec it. These smaller Blue Nova batteries, are you talking about very small Blue Nova batteries, because they come from gate batteries to higher kilowatt units?
Yeah, I've actually got a bank of two of the big 8 kVA double pack Blue Novas.
Yes, I mean, if they spec it correctly, you need to have a look. What's your kilowatt hour need? What's the rating of the inverters that's going to consume that power, or convert it into AC? And this battery spec of the battery specs, especially if you cut it fine, if you just cut it above the inverter rating, then this is very important. And then if you scale it up and have a lot of these units in parallel, then it becomes less important. But this is important, what a requirement is. This will determine how long you will have power for your specific need. If you have a constant 3 kilowatt draw and you need it for 10 hours at night, then you need 30 kilowatt hours of batteries at least.
Yeah.
It's just maths.
Yeah, no, that's fine. It's just, typically we've over the years with the lead acids, we've spoken about amp hour rating of battery, and now it's the conversion to the thinking around kilowatt hour, and the batteries are typically sold as kVA batteries. It becomes quite confusing for the layman to understand what he's actually getting into and what he's being cajoled into buying, as opposed to what he needs. But yeah, look, I know it's a bit more of a technical question to answer in a forum like this. But
sorry, the big answer is do not buy lesser batteries, lesser known batteries. It needs to be well established to the market. Google searches will typically take you down a drain. You need, we've dabbled in various types of batteries in the past, and then you disregard the units that has a a high rate of defects, and after sale service. You know, there's a few factors that you need to determine what batteries you need, but definitely you need operational hour or exposure to operational hours of certain battery systems. You need to look at warranty periods, because that will typically tell you what the manufacturers, you know, their confidence in their own batteries are. If it's 1 year, stay away. If it's 10 years, perfect.
Yeah.
Yeah.
And then if we can just touch on the question about the firefighting, the you know, the fire extinguisher requirements for the lithium fires, because I know it is different to anything else.
Yes. So heat management is very important. If a battery runs hot, it needs to shut down. There's parameters that you set up in your system to have that happen. The battery packs, again, need to be of high quality. The units that burn are not good quality batteries with bad battery management systems built in. You know, it can't be emphasized enough. If you buy bad quality batteries, you will expose yourself. Now, in terms of installation, you separate batteries from each other so that you can have, if you have a thermal runaway for, you know, and I must emphasize it. If it's a good quality battery, it you know, it needs to be a very special circumstance for it to start burning, But when you have a lithium fire, you do not douse that flame or that energy coming out. Those batteries store a hell of a lot of energy, so you keep the surroundings cold by maybe dousing it with water, but you cannot extinguish a battery pack. If it burns, it burns. If it's a car, a battery operated vehicle, same thing applies. You know, you just keep the surroundings cool with water. So
it's just a case. It's a case of essentially limiting the extent of the damage.
Yes. So
let the battery burn.
Let the battery burn, and preferably, you know, your spacing is important. You know, heat travels up. So and there's sons, you know, we have guidance from intelligent humans that gave us the prerequisites for installs. You know, we separate batteries by 500 millimeters. Some guys put it right 5 millimeters apart. You know, that's dangerous. On the other hand, you know, if we do high voltage applications, we have 600 volt battery packs. You have 12 batteries stacked on top of each other. And then you can have 4 or 5 of those units that's separated. So you have now, instead of 1 or 2 5 kilowatt hour batteries, you have 12. And they like, it looks like a server rack. You know, it's, you know, there's a confidence level that you need to have when you put these things together. It's let me just show you this one. I don't know if you saw it in a presentation. Let me just show you these units. This is a Daya battery stack, 600 volt. I think it's 700 volts. But each of these batteries has its own battery managed system. It reports that to a controller on the top. That controller reports to the inverter. That data is sent through to us. But if those parameters are monitored, if the battery pack goes over a certain temperature value, It needs to shut down, well, a warning point, a shutdown point. There needs to be a stable internet connection. That's the important things. If the chance that the battery, well-installed, monitored, good quality battery pack from thermally running away is much less than driving, getting killed in a car. There's millions of installs out there, and a percentage of specific types of batteries running away, that's so low.
Sure. Thank
Yeah.
you.
Pleasure.
Thanks.
Thank you, Hedley. Okay, Mr. Skuman and then Mr. Van Wyk after him.
Thank you, Julian. Good afternoon, for sure. Very insightful presentation. Thank you very much. I had a quick break in transmission. I hope I didn't miss it. My question is for you to possibly explain to me the difference between a pure sine wave and a modified sine wave inverter, and which one would be preferable to use if you are going to employ very sensitive electronical equipment, like metering, meters, sensors, that sort of thing. A lot of our workshops run fairly sensitive diagnostic equipment. I just want to understand the difference between the two, because I know there's also a price difference. Thanks for sure.
No, absolutely, Jan. The worst case scenario for inverter output is just a square wave. So if you look at the design of an inverter, you basically take a DC voltage and chop it. A DC voltage, has a constant positive voltage, for instance, 50 volts. So what you do is you take that 50 volts, in terms of a square wave, you take that 50 volts and you switch it positive and negative, and you reverse the polarity of that DC voltage. So you'll get a plus 50, minus 50, plus 50, minus 50, 50 times a second, or 100 times a second. So 50 pluses and 50 negatives. If you run an electric motor on that output, you'll hear that something's wrong. So that's highly undesirable. Modified sine wave will not be a square wave output, but squarish. So if you look at it, it will have the output will look like little steps in the output. So they will, for instance, switch it 25 volts for a quarter of the cycle, and then 50 volts for 50% of the cycle, and then 25 again for a quarter, and then the negative component. So it's a bit better, but for diagnostic equipment and sensitive stuff, not desirable. Pure sine wave, they use pulse width modulation at a high frequency so they will, instead of doing this 4 times in a positive cycle, they will do it 5,000 times. So they will gradually increase the width of each little pulse, smooth it out with capacitors, and the output of that inverter, you will not distinguish it between the output of a generator or the output of an inverter. While addressing the next question, I'll just Google quickly and show you physically how it looks. But a pure sine wave output, that you'll only get with your higher end hybrid inverters, and your little trolley units, they will have either modified or just square wave stupid outputs. Does that answer your question?
Yes, thank you for sure.
Okay.
Thank you, Jan. Martin, you can go ahead. Martin, I'm not sure if you're muted. Put your hands up. Perhaps Martin's having some technical difficulties as well. Okay. In the absence of Martin speaking, is there any other questions we have for Fouché?
Well, just to get back to that previous question, if you can look here, this is a square wave inverter, just switching on and off. Here's your modified sine wave, so it has little steps. But you can see they want to approximate a sine wave. This is a sine wave output. Sometimes it's audible. You hear a hum. That hum will be this switching at a very high frequency, and then you get this nice sine wave output. Okay.
Okay, and thank you for sharing. I see there are no other questions, so I would just like from my side to thank you for this presentation. A quick question, would our members be able to contact you should they need any advice or more
Absolutely.
information? Okay, then
Absolutely.
can I just ask, maybe can you perhaps just type in your details in the chat?
No problem.
If you don't mind, and then I'd invite our members, please, as Fouché has graciously allowed. If you have any questions or any information, more information required over and above what you learned here today, or even, as I said, I have sent the booklet out to those who couldn't find it on the chat. I'm not sure why that happened. So once you go through that, if there are further questions, please feel free to contact Fouché, and I'm sure he will assist in any way possible. And
There
with
you
that,
go. I've copied.
ladies and gentlemen, oh, sorry, was it? Oh, yes, I can see it there. Yes, thank you. Thank you, Fouché. So with that, again, Fouché, I'd just like to say thank you to you for your excellent presentation. And to the members, thank you for your time. Thank you for joining us. I hope this has been beneficial to you. For your other, perhaps maybe other colleagues, there will be a repeat of this on the 6th of November. But Danelle will send out communication on that in the days to come. And with that, thank you very much and have a lovely evening. And we'll all chat again soon. Thank you.
Thank you.
Thank you very
Have a nice
much.
day.
Cheers. Thanks, Fouché.
Thank you. Thank you. Bye-bye.
Thank you. Bye.
Thank you, guys. Bye.
Thank you.
Thank you.